Welcome back, everyone. Thank you so much for tuning in today. Today we're going to take a look at the derivatives of the cosine, the sine, the e to the x function, and the natural log function. Starting off with the derivative of the sine function. The derivative of the sine is just the cosine function. And the derivative of the cosine function is just the opposite of the sine function. And here we have a proof of that first derivative, the derivative of the sine function. So we start with the limit definition of derivative. And then this is a sine alpha plus beta formula that you probably learned in pre-calculus. The next step, we just do some rearranging of terms, which allows us to then factor a sine out of these two terms, which you can see here. And since we're taking the limit as h approaches 0, the sine of x is really just a constant. So we can take that out in front here, leaving us with this limit that we know, we have hopefully engraved into our heads, is 0. And over here, same thing, we take the cosine out, leaving us with this limit, which we know is 1. So we have 0 times sine, which is 0, and then 1 times cosine, which is cosine. And you can do the same thing for the cosine proof as well, as long as you know your cosine alpha plus beta formula. Let's take a look at it using these derivatives. They're pretty simple once you get the hang of them here. So first we have y equals 2 sine x. So the derivative of y with respect to x is just using our constant multiple rule, 2 times the derivative of sine, which is cosine. So the derivative of 2 sine x is 2 cosine x. Remember, for problems like this, we want to take a look at that denominator. We want to think of it as 1/2 sine x. That's how you want to think about it. Whether you rewrite it or not is up to you, but thinking about it that way is beneficial. So then the derivative of that would just be 1/2 times the derivative of sine, which is 1/2 cosine x. And for C, the derivative of x is just 1, and the derivative of positive cosine is negative sine. So our derivative would be 1 minus sine x. Next, we have the derivative of the natural exponential function, which is the craziest derivative, in my opinion, because the derivative of e to the x is e to the x. So the derivative of 5 e to the x, believe it or not, is 5 e to the x. For b, the derivative would be e to the x minus 4, because the derivative of negative 4x is minus 4. And then for c, we're using a couple things we're learning today. So the derivative would be 7e to the x, and the derivative of cosine would be negative sine. So 7e to the x minus sine x would be our derivative of that function. Next, we have the derivative of the natural log of x. This one actually does come up quite a bit in our endeavors here. The derivative of the natural log of x is equal to 1 over x. So here we have, using a lot of things that we learned today, find the derivative of this function. So we're going to say, all right, the derivative of y with respect to x is 3 times the derivative of natural log of x, which is 1 over x, minus 2 times the derivative of e to the x, which is e to the x, minus 1/2 times the derivative of cosine, which is negative sine. All right, so cleaning this up, we can rewrite our final answer here for the derivative to be 3 over x minus 2e to the x plus 1/2 sine x. The derivative of a log that's not base e. So the derivative of a log of some other number base not e, but any other number of x, is 1 over the natural log of that base times 1 over x. Or in other words, 1 over natural log of b times x. Okay, we're not going to do any problems with that, but we're just going to kind of show you how that works here. Remember that from pre-calc, log base b of x is the same as natural log of x over natural log of b. So if we're trying to find the derivative of that, that's basically saying on the derivative of that function, we can rewrite that as y equals 1 over natural log b times natural log x, because 1 over natural log b is just a constant. So our derivative then would be 1 over natural log b times 1 over x. And hey, look at that. That's the same thing we came up with there. All right, so using a couple of these derivative rules, we're going to go back to our limit definition of derivative and practice recognizing some of these. So remember our general derivative and our derivative at a point rules here. We're being asked to evaluate this whole expression, which looks really daunting. But we know all this question is really asking us to do is to take the function sine of x and find the derivative at some value. The question is, what is that value? Well, so at this point, all we really got to do is figure out what the c value is. And then we should be able to find our derivative at that point pretty quickly. So we want to ask ourselves, when is the sine equal to positive root 3 over 2? Okay, and that's based off our unit circle knowledge that you hopefully have not lost over the past couple months. So the sine is equal to root 3 over 2 at a couple different parts, but in the first quadrant, it's at pi over 3. So our c value is pi over 3. So really, all this question is asking us is, what is the derivative of this function at this point? We don't need to go through that whole limit process to do this. We can simply take the derivative, which is cosine x, and then find the derivative at that point. And the cosine of pi over 3, if you don't recall, remember pi over 3 is a 60-degree angle. So the cosine of that would be 1/2. Okay, so our original limit is equal to 1/2. And now we could write a tangent line if we wanted to, or a normal line if we wanted to. But we don't need to, we just want to know what that limit was, and the answer is 1/2. Okay, same thing for part B. Again, we just want to know what the function is and what the c value is. Okay, so the function is right here. It's just natural log of x. So f of x is natural log of x. To get our c value, you want to think natural log of x equals 1 when? Remember, you can change this from logarithmic to exponential by going e to the first equals x. So therefore, x is e. So our c value is e. So taking our derivative, we get 1 over x. And f prime of e would be 1 over e. And that's the best we can do without a calculator. 1 over e would be our answer to this limit. All right, that'll do it for our lesson on the derivatives of sine, cosine, e to the x, and natural log x. Thanks for tuning in. See you soon.